Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Welcome back to my channel. So today we're going to be doing practice problems for limit laws. If this is the first limit law video of mine that you're watching, just know that there is a video that I did previously for practice problems where I explained limit laws by doing practice problems rather than doing an entire introduction for it. When I'm done with this video, I'm going to make like a full-on introduction of limit laws. So in case that video has already been uploaded when you're just watching it, and if you're not very good with limit laws, you can watch the introduction video and then watch the previous video I made before this one and then watch the practice video. Or if you decide you just want to learn by practicing and doing problems, then this video is for you. So I have written like a whole bunch of questions. We're going to solve all of these questions, but they're going to be solved in no particular order of how they are on the screen. Instead, they're going to be solved based on order of difficulty. So I wish you guys all the very best, and let's go on to start solving. So the first question we had the limit of 6x minus 17 as x goes to negative 3. So the first thing you have to do is you're given a question like this, and you're given the function, and the function is 6x minus 17, and you're given the input value for x, which is negative 3. All you have to do is just basically apply the limit law, and the way you apply the limit law in a question like this is just you end up with the limit of 6x, right? Or limit as x goes to negative 3 of 6x minus the limit as x goes to negative 3 of 17. Hence, the minus is coming from this one here. That's where we get minus. And that's what you're going to do. The next thing you have to do is you bring out the 6. Then you have 6 multiplied by the limit as x goes to 3 of x, right? Minus the limit as x goes to negative 3 of 17. The thing you have to do here is this. Looking at the limit law formula, where you have negative, you're looking at the limit law formula when you have a question like this has a variable, and the variable in this case is x, right? But we know x goes to negative 3. All we have to do is just substitute negative 3 here. So we end up with 6 multiplied by negative 3, right? Minus this. So now we have the limit of a constant as the variable, in this case x goes to negative 3. What you're supposed to do is this. Anytime you're given a limit of a number or of a constant, whether the constant is a fraction, a decimal, a whole number, like we have here 17, because you're asked to solve the limit of a constant, and there is no variable here that you can input the value into, like you don't have 17x or 17x squared or anything like that. The constant stands by itself, so therefore you're not going to substitute anything. You're just going to let 17, which is the constant right here, you're just going to put that right here. So we're going to end up with 17 here. So basically the limit, right, of a constant c as x goes to a particular input or number a is always going to give you c. The constant is what you're going to use. So then you have then you have 6, right, times negative 3. 3 times 6 is 18. 3 times negative 6, 6 times negative 3 is negative 18. Negative 18 minus 17. We end up having that to be negative 35. So one thing I mentioned in the last video I made while I was doing practice problem is to remind you that for limits, you're always going to get your actual answer to be actual value. You're not going to get it to be in terms of you're going to get it to be in terms of like a variable. It's always going to be in terms of an actual like number. So, and this negative 35 is actually like the y value. while 6x minus 7, right, is the function, and x going to -3 is just basically the input for x. So that's one thing you should know, like putting in the value into a function, you're gonna get an actual number, and that number is always is what you would know as, or what is known as the y value. So that's just a short way of like, that's just a short explanation. I talked about it in the last video, but now we're in a new video, so it doesn't hurt to keep repeating it. So the next thing we have is a limit of 5x cubed. So we have the limit of 5x cubed minus 3x squared plus x minus 6, all of that limit as x goes to 3. So this is our second question. Well, this question is very similar to the first one. The only thing is that this has more higher values for like polynomials. And what I expect that you do first, what is expected to be done, is just do the first thing that we did previously. You're going to expand. So you're going to have the limit, okay, as x goes to 3, right, of 5x cubed minus the limit as x goes to 3 of 3x squared plus the limit as x goes to 3 of x minus the limit as x goes to 3 of 6. So this is basically what you're supposed to do. This is literally what has to be done first. Now that you've broken down the information into smaller bits, what you can end up doing is for you to substitute wherever is necessary. So you have this x equals to 2 here can be substituted here. X equals, or x going to 3 here can be substituted here. X going to 3 here can be substituted inside here. And then this is a constant value, so therefore whatever x goes to doesn't have any significance because it's a constant here. So therefore what we'll end up with is bringing out 5 first of all. So we're going to have 5 multiplied by the limit as x goes to 3 of x cubed, easier to see, minus 3 multiplied by the limit as x goes to 3 of x squared plus the limit as x goes to 3 of x minus the limit as x goes to 3 of 6. So now we can successfully substitute. You put this here, and you may be wondering, why didn't I just do it like in this step? Why didn't I just substitute in this step? You can do that, but because of we're dealing with like higher powers, it's smarter for you to bring out any of this like constant multiple, like the coefficient of x cubed here, the coefficient of x squared. You don't want a situation where as you're solving, because you're skipping steps, your work starts to get confusing, especially now that we have higher power numbers, like we have x cubed, x squared. You don't want anything to be confusing. So it's really smart for you to bring out the 5 this first term and the 3 the second term. But if you've been doing limits for a while and you're confident in your mathematical abilities and capabilities, and you know that you're not someone that like easily makes mistakes and you can think problems out in your head, you can skip this step. But because this is like a wide variety of audience that will be watching this video, I think it's just wiser to break the information down. So you end up with 5, right, multiplied by, we're going to input 3 here, so multiplied by 3 cubed, right, minus 3. So then we're going to substitute there. We have 2 squared plus, what do we do here? We substitute. So plus just 3. And then we have the same constant multiple situation right here. Remember what I explained. The constant multiple is just, not constant multiple. We have a situation where we're supposed to take the limit of a function, and the function in this case is a constant. So therefore, the constant is going to actually be the answer to the limit of the constant as x goes to a particular value. So we're just going to put down 6 right here. So 5 multiplied by 3 cubed. 3 cubed is 3 times 3 times 3. 9 times 3 is 27. So we have 27 here minus 3. And then we have, oh no, not 2 squared actually. This is 3 squared. So here, when we have 3 squared is what? 3 squared is 9 plus 3 minus 6. So 5 times 27 is, so we got 5 times 27 to be 135 minus 3 times 9 is 27. So we have 27 plus 3 minus 6. When you input that into a calculator, you have the answer to be 105. So this is basically your answer right here. Before we go further, I just want to quickly point out something. Whenever you're asked to find the limit, okay, of a function, so limit as, say, the variable x goes to a, and you're given a function f of x right here plus g of x, the first thing you have to do when you're dealing with limits is for you to expand. So you end up with the limit as x goes to a of f of x plus the limit as x goes to a of g of x. So that's just one thing I want you guys to know. That is the same method that I applied here. I'm only going over this part, even though we're doing practice, just so any student that may be confused, you should just know that like math is always about simplification. And part of simplification is to solve something. So don't ever feel like you're being too slow or being unnecessarily rigid when you're breaking things down, especially if you're learning for the first time. So this is it. So this is what it breaks down to. If you're dealing with something that has a negative number, so like a subtraction information, like so instead of f of x plus g of x, you have f of x minus g of x. The same thing is to be done. You end up with the limit of f of x as x goes to a minus limit of g of x as x goes to a. So this is basically like what needs to be done. So that is what we just did here, right? We just literally did this and voila, we got the answer to be what we got the answer to be. So I wanted to put this information and break it down because we're done now with more direct polynomial functions. Now we're going to move to more advanced questions. The next question that we're going to solve is we have the limit as x goes to 6 of 2x minus 1 multiplied by the square root of x plus 4. So this is our next question, and the first thing you have to do is, if you've been doing limits for a while, you probably already know what to do. The first step, but I'm going to explain it, is for you to do this. Is for you to do something that's similar to expansion, but not exactly. It's for you to apply the product rule of Limitless. So when you have a question like this, you're going to apply the general formula, which is the limit as x goes to a of, say, two subfunctions, f of x multiplied by g of x. You're just going to apply the product rule of Limitless. So what you end up with is the limit as x goes to a of f of x that's 1, multiplied by the limit as x goes to a of g of x. And that is how you solve this. So now that I've put down the general formula, we're going to apply the general formula to this question. So we end up with the limit as x goes to 6 of 2x minus 1, okay, multiplied by the limit as x goes to 6 of x plus 4, and that is basically what is to be done. And now that you've done this, what you now have to do is to first of all find what this answer is, the limit of 2x minus 1 as x goes to 6 multiplied by whatever this answer is for the limit of the square root of x plus 4 as x goes to 6. Whatever this answer is and this answer is, just multiply them together and you're going to get what the actual final answer is for the question that we first of all were given. So I'm going to continue solving on the next page. So I'm just going to rewrite what we had last. So we had the limit as x goes to 6, right, of 2x minus 1 multiplied by the limit as x goes to 6 of the square root of x plus 4. So this information right here is what we're going to start with. Let us start with this. We're going to do both of them simultaneously actually. So what we're going to do is, remember what I explained? When you're given a question that looks like what is up here, up top, with like the green arrow on both sides, we're going to basically expand because that's what we're supposed to do next. We're going to expand. So you have the limit as x goes to 6, right, of 2x minus the limit as x goes to 6 of 1. All of that information multiplied by taking the limit here, as x goes to 6 of x right here, okay, plus taking the limit as x goes to 4, the limit as x goes to 6 of 4, limit as x goes to 6 of 4, all of that information like this. Does that make any sense? Hopefully it does. And that's how you're supposed to do it. So, one thing I need to explain though is this. If you're given a limit, actually, let me not make it that big. Just gonna put it at the side corner here. If you're given a limit as x goes to a of this, of a function f of x, the way you're gonna apply that limit is actually for you to get the square root of the limit of f of x as x goes to a. So that is the same thing we're trying to do here. That is really what is going on here. So yeah, that's basically it. So let's do this side first because it's easier. So you have the limit of 2x. Well, we're going to bring out 2, right? And we're going to do multiply by the limit as x goes to 6 of x minus this one here. You know that the limit of a constant, despite wherever the input value of x is going to, or what it is, despite whatever the input value of x is, it's just going to be the constant. So we're just going going to put a negative 1 here, multiplied by this one here, so multiplied by this whole thing here. So yeah, we're just going to do the limit. This one would be imputed here. This one would not need to be imputed because what we have is a constant, so we can just drop that down. So we end up with limit of x as x goes to 6. We're just going to input 6 and substitute x for 6. So we're going to have 6 plus the limit of a constant. What is the constant? The constant here is 4 as x goes to 6. We're just going to put down 4 because there's really nothing that you can input. The answer is just going to be 4. So you have that information. Remember, all of that is square rooted. But whenever you want to change square root into something else, you know that, for example, the square root of 4 is the same thing as 4 raised to the power of 1/2. The cubed root of x is the same thing as x raised to the power of 1/3. The fourth root of 50x is the same thing as 50x raised to the power of 1/4. We're going to use that same understanding here. So instead of us to do 6 plus 4, right, raised to the power, instead of us to do 6 plus 4 square root, instead of us to do the square root of 6 plus 4, instead we're going to do 6 plus 4 raised to the power of 1/2. That's it. It's slowly coming together. So you have 2. Now we're just going to substitute here. So 2 times 6, right? 2 times 6. Let's that one first. And minus 1, okay, multiplied by 10 raised to the power of 1/2. So therefore you have 2 times 6 is 12. 12 minus 1, right, multiplied by the square root of 10, because we're going to turn it back into a square root. So what we end up with is 12 minus 1 is 11. So 11 multiplied by square root of 10, which makes our answer just 11 root, or 11 square root 10. So this is the answer. I want to say something. For anybody that may have been confused in the way I solved this problem, first of all, I apologize. Secondly, I have to say, this is one of those things where you have to practice. I know that I started with pretty easy questions and then boom, I brought a question that looks like this. This is what you call the product rule for limitless. So let me just quickly do that. I'm going to quickly re-explain it, just in case people are confused, because the whole point of me teaching this is to help students, not necessarily to just make it easier on myself. We had a question, right, that involved a function that involved 2 sub-functions multiplied by each other. So we applied the product rule for limitless, and what we did was to first of all show what the general formula looks like, which involves taking the limit of each sub-function and separating them first of all, and then you get what the y value is, the actual value is, multiplying them by each other. So that's what I was explaining at the bottom. Then we started to do that. We took the limit of one of the sub-function. One of the sub-function is 2x minus 1. The other sub-function is the square root of x plus 4. We found the limit of the first sub-function, which was what we did. We did right here, underlined in green marker. And then we did it for the second sub-function, what we did right here, underlined in green marker. I explained on the right hand side, the mini box that is in red, the mini red box, that when you're asked to find the limit of something that has a root, right, as what you have to do is, first of all, find the limit of the function and then get the root of the answer. And that was what we did. And we got that to be the square root of 10. On the right hand side, we got all the solution, the substitution on the on the left hand side, all of that solution, substitution, You ended up getting an answer to be 11, and then the answer on the right to be square root of 10, because we're applying the product rule. Now that we have what the two sub-function answers are, we multiply them together, so we ended up with 11 root 10. Hence why our answer is 11 root 10. So if you're ever given a question that looks like this, just know that that's what the teacher expects from you. So now we're going to go to the next question. Oh yeah, let me clear this frame. So we have 3x squared, the limit of x of 2 of 3x squared minus 5x plus 2 divided by x to the 4th plus 6. So 3x squared minus 5x plus 2 divided by x to the 4th plus 6. So the first thing you have to do is to understand that we're supposed to first of all apply the product rule of limit laws, which is basically this. I'm going to write it at the bottom. You have the limit as x goes to a of f of x divided by g of x, which is the same thing as getting this, which is limit as x goes to a, that's the general formula of f of x, right, divided by the limit as x goes to a of g of x. So that is what you're supposed to do. That's what it's supposed to look like, the general formula. Now we're going to apply the understanding of the general formula to our actual question. So here we're going to end up with the limit as x goes to 2 of 3x squared minus 5x plus 2 divided by the limit as x goes to 2 of x to the 4th plus 6. And that is going to be the first application of the quotient rule of limit laws. I'm going to write that here. For those of you who are seeing this for the first time, this is what it is. Quotient rule of limit laws. I want to mention something. So, even though this video that I'm currently making is for students who have some level of understanding of limit laws, and what you're watching this video for is mainly for practice so that they can get better understanding and they can be faster with the way they think and think through things. Alhamdulillah, that's good. Thank God. One thing I want to mention is if you're still struggling, do not forget that I have an introduction to limit laws where every single of the limit law is explained, and you should go check my description box or go to my playlist on my channel to find it. So I just wanted you guys to know that. So if you've watched all of this video, and I would advise you to finish watching it, then go back and watch the introduction video, and then go and look for questions and see if you can solve them, or come back to watch this video and see if you can solve majority of these problems before I'm done solving it. If you can do that in your due to independent practice, then I would say that to an extent you already know how to solve limit law problems. At least you know how to properly attempt limit law problems, which is supposed to be the goal, because learning to attempt something is like half the work, honestly. So yeah, I just wanted you guys to know that. So we're going to continue this problem now. So you have this. What do you have to do now? We're going to do the limit, find the limit of the numerator. So we have that to be limit as x goes to 2 of 3x squared minus the limit as x goes to 2 of 5x plus the limit as x goes to 2 of 2. All of that divided by the limit as x goes to 2 of x to the 4th plus the limit as x goes to 2 of 6. So yeah, that's it. That's basically it. So that's the answer. Well, that's not the answer. That's that's how you break it down. Now the next thing you do is to start solving. So at this point we know that we're going to substitute 2 here, substitute 2 here, substitute 2 here. We're gonna do all of that, but I'm still gonna still gonna try my possible best to break it down. So first we have 3, because we're bringing that out, times the limit as x goes to 2 of x squared. If you want to skip this step, you can go ahead to do that, but I'm gonna do it just for the purpose of clarity for everyone. Minus, bring out 5 multiplied by the limit as x goes to 2 of x, okay, plus, what is the limit of a constant as the input x or the variable x goes to a particular number? Well, it's just going to be the constant. There's nothing to substitute there, so we're just going to bring 2 down. And then here, we have the limit of as x goes to 4. So you can just do that and put, I'm just going to put limit. And we're going to rewrite what we have as x goes to 2 of x to the 4th, okay, plus the limit of 6 as x goes to 2 is just 6 here because it's a constant, so we can easily bring it down. So now that we have that information written down, we can go on to solve it. So we have 3. We're going to start substitution. X is 2 here, 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 right? So we have 3 multiplied by 2 squared minus 5 multiplied by 2, because we're substituting 2 there, plus 2 divided by, we're going to have 2 to the 4th plus 6. That's it. 2 to the 4th plus 6. So going into the next page, we have, I'm going to rewrite what we just had here. So we had 3 multiplied by 2 squared minus 5 multiplied by 2 plus 2. Divided by 2 to the 2 raised to the power of 4 raised to the power of 4 plus 6. So you have 2 squared is 4. 4 times 2 is 12. 12 minus 5. Sorry, 12 minus 2 times 5, so 12 minus 10 plus 2 divided by 2 raised to the power of 4 is 16. So 16 plus 6. And what we end up with is 12 minus 10 is 2. 2 plus 2 is 4. So 4 divided by 22. We will simplify. So we end up with 2 and 11. So our answer is 2 over 11. So therefore, this question here, the limit of 3x squared minus 5x plus 2 divided by x to the 4th plus 6, when we apply the quotient rule of the limit law first, in order for us to be able to break down, because we can see that we have a question where there's a numerator and a denominator. We're going to first of all apply the quotient rule for limit laws. We break that down. When we do that, we can now expand the function using the limit. When we go ahead and we do that, then we're going to solve each individual limit. When we're done solving each individual limit, we either add them up or subtract them depending on whatever sign we're given, and then we divide by each other, and that was basically what we did here. We got our answer to be 2/11. If you're confused, make sure you pause the video and then rewind and go back to it to be able to understand it better. Maybe if you watch it twice, it might be easier for you. So that's the next question. So now we move to the next question. We have the limit as x goes to 4 of 2x to the 5th minus 18x squared plus 3, all of that divided by 3x cubed minus 19. So that is basically what we have. Now, because you can see that we have a numerator and a denominator, what we have to apply is basically the quotient rule. So the first thing you do when you're applying the quotient rule is basically apply the limits in the numerator, just like we did in the previous question here, and also apply the limits in the denominator. And then that's the first thing you have to do before you can go ahead and successfully start solving. So what we end up with here is the limit, applying the limit as x goes to 4 for the numerator. So we have 2x to the 5th minus 18x squared plus 3, all of that divided by the limit as x goes to 4 of 3x cubed minus 19, and voila, that's the first thing you have to do. Next, we can now expand the limits for both the numerator and the denominator. So we have the limit as x goes to 4 of 2x to the 5th minus the limit as x goes to 4 of 18x squared plus the limit as x goes to 4 of 3 divided by the limit as x goes to 4 of 3x cubed minus the limit as x goes to 4 of 19. So that's it. That's really what is going on here. And yeah. So the next thing you have to do is, now that you've basically done that, let us continue as we always do. We're going to bring out 2 multiplied by the limit as x goes to 4 of x to the 5th, okay, minus bringing out 18 multiplied by the limit as x goes to 4 of x squared plus the limit of 3 as x goes to 4. One thing that is important for you guys to know is that this style of bringing out the coefficient of the variable in the function that I do, like bringing out 2 and then isolating the limit of x to the 5th, or bringing out 18 and isolating the limit of x squared. The reason behind that is whenever you're now given a question where may be more difficult for you to multiply, because I've noticed something when people are studying calculus or doing more advanced classes, they know how to think about algebra, we know how to think about like a lot of stuff, but whenever it comes to like the easier stuff like 12 times 11, you can see like some mathematicians struggle. It is good for you to break down questions where you may potentially have big numbers to multiply, or to multiply, or to get the power of like 5 raised to the power of 5. Might not be the easiest thing to do for some people, but thinking through a major calculus problem is much easier for them. So that's the reason why I'm bringing things out, because then at least you have an opportunity to properly use your calculator to think through the problem. So that's my thinking through it. And if you want to skip this step while you're writing it in your book, or while you're taking notes, you can go ahead to do that. That's your choice. So then you bring out the limit as x goes to 3 of x cubed right, minus the limit as x goes to 4, not x goes to 3, that's my bad, x goes to 4 right here, and yes, the limit as x goes to 4 of 19, right? So the next thing we have here is 2 times, before we go ahead, remember, x to the 4th here can be substituted here. Just look at what I'm doing in black marker. X to the 4th can be substituted into here. X to the 4th can be substituted into here. So therefore, what we end up with is 2 times 4 to the 5th. We make it consistent. Back to red marker. 2 times 4 to the 2 times 4 to the 5th, right? Minus 18 multiplied by x squared, so that we multiplied by 4 squared, right? Plus, we have a situation where we're asked to find the limit of a constant. The limit of a constant as a variable, in this case, x, goes to a particular input value. It's not going to have any effect on it, so we're just going to have the constant. So we're going to put 3 here. And then we have here, we have 3 times, we have 3, I'm sorry, I don't know why I keep saying 3 in that part. 3 times 4 power of 3, so you have that, okay, minus limit of 19 as x goes to 4. The limit of 19 as x goes to 4 is what? Well, what we have is the limit of a constant as the variable goes to a particular value, input value. So you have that to be the constant. So you have 19 here. So you have, you have that to be 19. So you have 2 times 4 times 4 times 4 times 4 is 1024, okay, minus, so 4 to the 5th is 1024, minus 18 times 4 squared is 16, so that, plus 3, all of that divided by 3, 4 times 4 times 4 times 4 times 4, sorry, yeah, like 4 times 4 times 4 times 4 times 4 times 4, that is just basically 64. I see that I made a mistake here, so this is not 4 raised to the power of 5 here, this is 4 raised to the power of 3. Just rewrite that in your notes. So minus 19. So that is how you do it, and then we're going to the next page. I'm just going to rewrite what we just had here. So you have 2 times 1024 minus 18 multiplied by 16 plus 3, 3 times 64 minus 19. So you have this, which is going to be 2048 minus 288 plus 3 divided by 192 minus 19. So when you do it, put it in your calculator and everything, what you end up with is 1763 divided by 173. So this is basically the answer. The answer to this entire question is what we have. 1763 divided by 173. So that is the answer to this question. Hopefully this is a question, hopefully this explains a lot better. If you are confused, just go back and trace everything I've explained. First of all, we have applied the quotient rule. Since we have a function that involves a division, the numerator and the denominator, you apply the function, you apply the limit on the numerator, and then you apply the limit on the denominator, then you expand the limit into the function, or expand the function using the limit, When you go ahead, you do that, you break down the information, you multiply, add whatever is necessary, and then you just simplify up until you get the final answer, which is what we already got. So now the next question we have is the limit as x goes to -3 of 2x plus 22 divided by x plus 3, and then up here we have -4. So this is the next question we have. Well, we're going to do it like we've done the other one previously. We can see that we have a question here that involves taking the limits, of course, because it's a limit question, but this time around we have a function that is a fraction. So we're going to take the limit of the numerator and the denominator. So we have the limit as x goes to -3, right, of the square root of 2x plus 22 minus 4 divided by the limit as x goes to -3 of x plus 3. You have the limit, you have basically this. So the next thing you have to do is to apply and expand. So we have the limit as x goes to -3 of the first information, which is the square root of 2x plus 22, so that's the first limit, minus the limit as x goes to -3 of 4, divided by the limit as x goes to -3 of x plus the limit as x goes to -3 of 3. So now we've kind of broken it down. We've applied the quotient rule for limit laws as well as we've expanded. The next thing we do is to apply it. So now we have a question where we have the limit of something that needs to have like a square root. Sorry, now we have a question of a limit of a function, and that function is enclosed in the square root or enclosed in a form that involves like a root. So maybe in another case you may have a question involving like a cubed root or a fourth root, but in this particular case it's a square root. But what you have to do is, I'm going to explain it. I believe we've done a question like this a few questions back. But when you're given a question that involves you taking the limit, you say x goes to a, or x goes to a particular value, in this case a, of the square root of f of x, right? It's the same thing as getting the square root of the limit of f of x as x goes to that particular value. So this is another law. We're going to now apply that law to this part of the question. So I'm going to change the color now to blue marker. So now we have the limit. So now we have, when we apply it, we're going to end up with, so we have now x, the limit as x goes to -3 of 2x plus 22. We're going to end up with the square root of the limit as x goes to -3 of 22x, of 2x plus 22. So this is the answer, basically. This is literally the answer. So now that we've done that, we can now start solving. So you have, we're gonna substitute here, and then we have the limit, okay, now we have the square root of the limit as x goes to negative 3 of 2x plus 22 minus the limit as x goes to negative 3 of 4 divided by the limit of x as x goes to negative 3 plus the limit as x goes to negative 3 of 3. So that is what we have. I'm going to rewrite this on the board in the next page. I think that will be better that way. So just so you can see much more clearly. So you have the square root of the limit as x goes to negative 3 of 2x, right, plus 22 divided by the limit as x goes to negative 3 of x plus the limit of 3 as x goes to negative 3. Well, let's not forget what is left at the numerator. So we have minus the limit as x goes to negative 3 of 4. So you have that down. Now that we've written that, what we end up with is we're going to substitute. So you have, you see x equals to negative, or x going to negative 3 here. We can substitute it here. We also know we can substitute it here. So we're going to go on to solve. So you have the square root, of course, of the limit as x goes to negative 3, right, of 2x, because we still got to expand, plus the limit as x goes to negative 3 of 22, minus the limit as x goes to negative 3 of 4, and here we have the limit as x goes to negative 3 of x plus the limit as x goes to negative 3 of 3. So we have this information down, and now we're going to start maybe working a little bit more turbo fast. So we have this to be the limit. We can now substitute here. We can now substitute here comfortably. So you have the square root still, because the square root is not going anywhere, of this. So that will be 2 times negative 3 plus 22, because we have a constant here, and that doesn't really have much of an impact, except that we're just going to still put a 22, and then the limit of 4 as x goes to negative 3 is just 4. So that's another thing here. And then we have this substituting, so we have negative 3 plus we have this here. This is another constant here, so that's 3. So that will be the square root of 2 times negative 3 is negative 6 plus 22 minus 4. Yay! Minus 3 plus 3. So you have negative 6 plus 22. 22 minus 6 is what? 22 minus 6 is 16. So you have the square root of 16 minus 4 over negative 3 plus 3. So you end up with square root of 16 is actually 4. So 4 minus 4 divided by negative 3 plus 3. So what we end up with is 0 over 0. Now, this is not the answer. This is an undefined answer. One thing I need to teach you guys is, for those of you who this is like the first Limitless video you're watching from me, you may not actually know this, but when I solved a question in the previous video, I made sure to put a question like that in this video too. So whenever you have a limit law question where you first of all solve it, you apply the limits to all that is required, and you have 0 over 0, what you have to do is, you're not going to apply the limit to the question first. You're going to first of all see if there's a way you can simplify the function and then apply the limit. So in a situation, okay, so in a situation when solving limits of function, very important that you know this, limits of function, okay, if the answer to the limit is gotten to be 0 over 0, this answer is undefined. Is undefined, and therefore the function would need to be solved. Please write this in your books, by simplifying the function first and then applying the limit. This is how you solve it, honestly. So even when you have a question where where it involves any form of factorization, any type of function. So far it gives you 0 for 0. What that is telling you is that you cannot apply the limit first. You're going to have to simplify that function, break it down a lot, and then you apply the function. When you do that way, you can actually find what the limit is. So it does not mean that limit does not exist. It just means that the limit is currently undefined due to the way you're solving it. But if you break and simplify the question first and then apply the limit, you're going to be able to get the answer, hence the y value of the limit. So yeah, that's basically it. So we're going to now rewrite this question, and we're going to solve it in the proper way in order for us to actually get what the answer is supposed to be. So I'm going to rewrite it. So we have the limit as x goes to -3 of 2x plus 22 minus 4 divided by x plus 3. So the first thing we gotta do is to break this down. We're going to just deal with the function itself. We know the function to be, function is equal to 2x plus 22 minus 4 divided by x plus 3. Right? This is the function. And for those of you who, I don't know, who may be wondering what is going on, just take your time. Don't forget, like, whenever you're solving math and whenever you meet a more difficult question than you've seen, what is required of you is to be patient and to think the question through. Half of the stuff in math involves thinking, and the other half involves, like, approaching and then doing it. And if you've done the practice a couple of times, the thinking becomes a habit, and you just naturally flow into solving questions. So you have this now, and this is what the function is. So hence we're going to simplify it. The way we can simplify a question like this, because it involves a root, we can multiply the conjugate of the numerator by the fraction. Like, we can multiply the conjugate of the numerator by the numerator and the denominator. So that's how you simplify. So I'm gonna do it now rather than just talking. So you have 2x plus 22, right, minus 4 has a conjugate of the square root of 2x plus 22 plus 4. So you end up with the square root of 2x plus 22 minus 4, okay, divided by x plus 3. So multiplied by, okay, when I multiply the conjugates, so you have the square root of 2x plus 22 plus 4 here, divided by 2x plus 22 plus 4. So that is basically that is basically it. So you have so now that you have this, you multiply through. So what we end up with is we're gonna multiply all of this. This is a lot of work, but still gonna multiply it. So we're going to multiply it using the FOIL method. For those of you who don't know, the FOIL method is, let me put that down. So that will be FOIL. So the first terms on for both like sides of what we're multiplying. So that would be, we have the square root of 2x plus 22, okay, and also write 2x plus 22. So we're gonna multiply that first. Then the outers. So this is the first of this term, the first of this term. Then the outers would be this 2x plus 22. Oh my gosh. Yeah. 2x plus 22, we multiply that by whatever is outer on the second part, which is just 4. And then you have the inners, which is negative 4, okay, multiplied by whatever is like innermost, which is multiplied by the other 2x plus 22. And then the last will just be negative 4 multiplied by positive 4. So that is basically how we're going to solve this. So now, this is just a side note. We're going to continue. So we end up with here, we end up with 2x plus 22 plus 4, the square root of 2x plus 22 minus 4, the square root of 2x plus 22, and then minus 16. So right, that's what's going on. And then we're not gonna do anything to the denominator. We're just gonna say x plus 3, and then here we're just gonna have this the square root of 2x plus 22 plus 4. So that's it for now. So you have this here, you have a positive here, you have a negative here. You cancel out, so you end up with 2x plus 22 minus 16. Plus 22 minus 16. 22 minus 16 is what? 22 minus 16 is just simply the same thing as 22 plus 6. Okay, so 22 minus 16 is plus 6, so that will be 2x plus 6. So that's that, divided by x plus 3, okay, multiplied by 2x plus 22 plus 4, right? All of that information. So now, how do we do this? I'm going to go to the next page and we're just going to rewrite what we had at the bottom. So we have 2x plus 6 divided by x plus 3 multiplied by 2x plus 22, not 20, divided by 2x plus 22 plus 4. So that would be 2, right? x plus 3. That would be x plus 3. 2x plus 22 plus 4. So cancel this out here, cancel this out. So what you end up with is 2 divided by 2x plus 22 plus 4. You see, this is basically what we have so far, right? Now, don't forget that we haven't actually applied the limit. What we just did was simplify the function. And we simplified the function from having the square root of 2x plus 22 minus 4 divided by x plus 3, and we simplified that to be 2 divided by 2x plus 22 plus 4. Now that's the simplified version. And remember what I explained here. When you have that first, the function would need to be solved by simplifying and then applying the limit. So now it's time for us to apply the limit. So we have the limit as x goes to negative 3 of this new simplified version of the function, 2 divided by 2x plus 22 plus 4. Yay! So now let's just do what we know how to do. It's the same thing we've been doing. So we have the limits here, numerator x going to negative 3 of 2, and then the limit here, okay, so x goes to negative 3 of the square root here, 2x plus 22 plus limit as x goes to negative 3 of 4. So that's what's going on here. And then we have the limit of that, and then we have 2, okay, because we're asked to take the limit of a constant, which is just going to be that constant, right? Divided by what we've done before, which is going to be the square root of, remember how whenever you're taking the limit of a square root is the same thing as getting the square root. So whenever you're taking the limit of a function that is enclosed in a square root, what you're just doing is getting the square root of the limit of that function, basically applying it. So we're going to do the same thing here. So divided by the square root of the limit of the square root of 2x plus 22 as x goes to negative 3 plus the limit of 4 as x goes to negative 3. So the limit of 4 as x goes to negative 3. So 4 is a constant, so we're just going to have 4 here. That's equals to 2 divided by limit as it goes to 2x. Sorry, the limit of the square root of 2x, blah, blah. Yeah, so that was my mistake, you guys. I'm so sorry. You know how I wrote the limit of the square root of 2x? That's not what we do. Actually, the square root that is enclosed is what it handles that. So you just have, looking at the bottom left, you have the square root of the limit of the function. The function here would be 2x plus 22. That was my mistake. I'm so sorry. So that would be here. And then we continue. That would be square root here. So that would be 2 times negative 3 plus 22 plus 4. Let's go to the next page. So that would be 2 times negative 3. Rewriting it plus 22 plus 4. So that will be 2 divided by 2 times negative 3 is negative 6 plus 22 plus 4. So that would be 2 divided by negative 6 plus 22 is the square root of 16 right here, plus 4. So 2 divided by square root of 16 is what? Is 4. 4 plus 4 is 8. So that would be 2 over 8. So therefore, we can divide both sides and we have our answer to be 1 over 4. So basically what we've been struggling and trying to work on for like forever has just been this. It's just for us to solve this. You can see the first thing we found out was when we had a question like this and we solved it, we applied the limits following the limit laws, how we've been doing it. So we applied that limit to the function. We did all that was necessary and required. What did we get? We got 0 over 0. Then we realized that this limit is actually undefined. But guess what? If we try to break down the function and apply all the mathematical concept and knowledge that is supposed to be applied whenever you're simplifying root, something that has a root, by multiplying the numerator and denominator of the fraction by the conjugate of that root, you end up breaking things down, multiplying through, getting the simplified version of the function, and then you apply the limit. And when you do that, when you're done applying the limit, you get your answer, in this case to be 1 over 4. So that's basically what we did. But I want to quickly do something and tell you guys something. So I don't believe that the question I gave you or the work is sufficient to be able to successfully work on it. Honestly, I'm not saying that people cannot handle it. So what I'm going to actually do is that I'm going to give you guys a new question. I'm not going to solve the question. I'm just going to put the question out here for anybody who is interested in working on it on their own personal time. They would handle the question in their own personal time. But guess what? I would wait to the very end of the video to tell you what the answer is. I'm not going to solve it. I'm just going to give you guys this question and I'll advise you guys to do it. So watch to the end of the video and I'm going to actually write what the answer is. So when you go solve it on your own time, you should make sure that you actually get the answer that I write at the end of this video. So make sure you keep watching. So the next thing that you do is, for the next question that we have is this. So we have the limit as x goes to 1, right? 1 over x plus 1 minus 1 over half, all of that information divided by x minus 1. So as you can see, all the questions I've been doing, they are increasing in order of difficulty. So we're just going to apply what we've always known the limits to be, which is applying the quotient rule, because it's a quotient rule problem. So you have the limit as x goes to 1 of 1 over x plus 1 minus the limit as x goes to 1 of 1 half, right? That is what's going on here. And we have the limit as x goes to 1 of x minus 1, right? Now we've basically applied the limit. Well, we can go ahead to expand the denominator. So you have limit as x goes to 1 of 1 over x plus 1, okay, minus limit as x goes to 1 of 1 half, all of that divided by the limit as x goes to 1 of x minus the limit as x goes to 1 of 1, right? Now that we've done that, we can happily substitute. So you have x goes to 1, we can substitute that here. And we also can substitute that here. So we end up with 1 over 1 plus 1 minus 1/2, right? Divided by 1 minus 1. So that would be 1/2 minus 1/2. 1 minus 1. So that would be 0 over 0. So, yeah, guess what? We're going to have the same issue. Sorry, no, we're going to have the same issue. We literally have the same issue as what we got. And we can see that 0 over 0 here is undefined. So therefore, we have to find a way to solve this. Well, the way we can solve is for us to, first of all, do what I had explained on the previous page. Remember? What I explained? Or whenever you have a situation where when solving limits of a function, if the answer of the limit is gotten to be 0 over 0, the answer is undefined, so we know that. Therefore, the function will need to be solved by simplifying the function and then applying the limit. So now let's go back to that particular question, and we're going to try to simplify it first, and then we can go ahead to solving it. So we have, I'm going to rewrite the question here. So you have limit as x goes to 1 of 1 over x plus 1 minus 1/2 divided by x minus 1. So simplifying the function would involve 1 over x plus 1 minus 1/2 divided by x minus 1. So that's the function, right? Because we're going to simplify this function. Well, we can see for the numerator of this particular function, 1 over x plus 1 minus 1/2, we can find the lowest common denominator, which is just basically 2 times x plus 1, and then we can simplify that way. So you have 2 here minus x plus 1, all of that divided by x minus 1. So you end up with 2 minus x minus 1 divided by 2x plus 2 divided by x minus 1. Okay. I just did 2x plus 2. So we end up with 2 minus x minus 1 is the same thing as 2 minus 1 is what? 2 minus 1 is 1. So we have minus x plus 1 divided by 2x plus 2 divided by x minus 1. Now that we're looking at our work, what is it that we can do to simplify this further? Well, if you remember, in the previous page of what we just did, we were able to cancel stuff out. We were able to cancel the same value with opposite sign out. But in this particular case, we can't really do that. There's nothing that we can cancel out. But one thing we can do is that we can factor out a -1. So we bring out a negative here, and we have negative x minus 1 divided by 2x plus 2 divided by x minus 1. So we end up canceling this out. So what we end up with is -1 divided by 2x plus 2. So this is actually a more simplified version. So now we have this. What do you do next? We're going to see if we can basically use this simplified version of the function and apply the limits to it. So we apply the limit as x goes to 1 of -1 divided by 2x plus 2. So that would be the limit of the numerator, the limit as x goes to 1 of -1, okay, divided by the limit, okay, as x goes to 1 of 2x plus the limit as x goes to 1 of 2. So that would be the limit as x goes to 1 of -1 is -1 divided by the limit of 2x as x goes to 1. So that would be 2 times 1 is 2 plus the limit of 2 as x goes to 1 is just 2 because it's a constant, right? So what you end up with here is -1 over 4. So our answer, honestly, is just -1 over 4. That is our answer to this question. And you can see that our answer is not 0 over 0. Never. Our answer is actually -1 over 4. That's why you have to do a lot of limit flow problems so that whenever you have situations like this, you're not really stuck or confused. You're not really stuck or confused on what needs to be done. You can literally do a whole bunch of problems. And if you notice the problems I'm giving you are not too easy, I made like relatively very easy questions at the beginning, just so your brain can start like working, and then I said to like start doing more advanced problems. So if anybody has more advanced problems that you would like to share, you can kind of write it as best you can in the comment section or send a link, put it in the comment section that other people can go and see the question maybe on Google or whatever. And if I have time, I'm going to look at that question and I'm going to solve it and put it in the video. So that is basically what this is. Now, if you remember at the beginning of the video, I explained to you that we're going to do a bunch of problems. And let us see what we've done so far. We've done this, perfect. We've done this, perfect. And this, perfect, perfect, perfect. We literally just did this one here. So double perfect. This and this. So what we actually have left is this question. And if you're a student that you feel like you can handle this problem by yourself, I think that particular problem, I am going to do it now. But if for whatever reason you wanna, do it yourself, first of all, that is fine too. But the question that we actually do have is the limit as x goes to 2 of this right here, which is 4x squared plus 2 divided by 6x minus 4. So now you can see that you can see this problem basically, right? You can see this, and the first thing you do, remember what I explained, whenever you're given the limit, right, of a function that is a square root, or that is a function that is enclosed in a square root, right, or any form of root, all you just have to do is the square root or the root, cube root, fourth root, fifth root, whatever root, that root enclosed in the limit of the function. So therefore you're going to find the limit of the function, ignoring the square root, and then put in whatever answer you get inside that square root. So that is what we're going to do actually to solve this question. So we have this. So what you end up doing is going to be, what you're going to end up with is the limit, right, as x goes to 2 of 4x squared plus 2 divided by 6x minus 4 is the same thing as this square root of the limit, okay, as x goes to 2 of this function here, that will be 4x squared plus 2 over 6x minus 4. So that is basically it. So you end up with this right here. So you have the limit as x goes to 2 of 4x squared plus 2, okay, divided by the limit as x goes to 2 of 6x minus 4. You can see the first thing I did is to apply this limit law here. That was the first thing I did. And then when I applied it, I realized that our actual function that is enclosed in the square root has is a fraction. So therefore we can apply the quotient rule. You can see first we're like how we're basically doing the whole thing. First we're applying the limit law that involves a root. Then we're applying the limit law that involves the quotient rule, which is basically whenever you have a function that is a fraction, right? So now that we've done it, we can now go ahead and expand and apply the limit law that is for signs like sum and subtraction. And sum and subtraction is just going to be us expanding, right? So you can see how many that we're just doing in this question. So you realize that the question is not hard, it's just advanced. It just requires you to think. So the limit as x goes to 2 of 4x squared, okay, plus the limit as x goes to 2 of 2 divided by the limit as x goes to 2 of 6x, okay, minus the limit as x goes to 2 of 4. Okay, so that. So we end up with this here. So the limit of this, so that would be 4. Okay, square root here. 4 times the limit as x goes to 2 of x squared. Okay, plus the limit of 2 as x goes to 2. So the limit of a constant is that constant divided by here we bring out 6 times the limit as x goes to 2 of x plus minus the limit of 4 as x goes to 2 is just 4 right here, so minus 4. So that's equal to 4 times, so x equals to 2, x going to 2 is going to be substituted here, as you can see in the red marker, with the circles and the arrows, and here as well in the denominator, we're going to substitute that. So we have 4, right, times 2 squared, okay, plus 2 divided by 6 times 2, okay, minus 4. Interesting. So I'm going to just rewrite what we have here. So that would be 4 times 4 times 2 squared plus 2 divided by 6 times 2 minus 4, plus. Okay, so we end up with 4 times 2 squared. What is 2 squared, please? 2 squared is 4, so 4 times 4 plus 2, okay. Divided by 6 times 2 is 12. 12 minus 4 is 8. So 4 times 4 is 16. 16 plus 2 is 18. 18 divided by 8. So 2 here 4. 2 here 9. But guess what? It's still in the square root. So yeah, never forget your square root. Your tutor almost forgot her square root. We're not doing that. So we have that here. Then we have still in the square root, right? Because we have to get the limit first and then apply the square root. So you have 18 divided by 4. When we broke that down or simplified that, we ended up with 9 divided by 4. So that's for the square root of 9 divided by 4. The square root is the same thing as the square root of 9 divided by the square root of 4, which is the same thing as what? 3. Okay, over 2. So therefore our answer to this entire unique question, this unique question here, is just basically 3 over 2. That's our answer. So we have come to the end of this video. I hope this video was very, very helpful to you guys. But not quite the end. I'm so happy for those of you who stayed this long. I know I promised you something at the beginning, or not at the beginning, earlier on. I said we should solve the limit as x goes to -1 of this particular function, 2 minus the square root of x squared plus 3 divided by 2 plus 1. Well, when you solve it on your own time and make sure to compare your work to what my work is, you're gonna solve and get the answer to be 1 over 4. So if you got your answer to be 1 over 4 while you're doing your own personal studying and you solve this question, if your answer is 1 over 4, your answer is correct. That's my point. So yeah, I wish you guys all the very best. I'm so happy you guys stayed with me to the end of the video. We'll try and work on this problem, and if you have a different answer, put it in the comment section so that if somebody else sees that, they can ask you and then you can explain. Or if no one else does, I'm going to be checking my comment section as much as I can, and then if I see you confused, I can walk you through where your problem is or what your mistakes are, and then hopefully you can resolve it again and you can actually get the answer to be correct. I wish you guys all the very best. Please like this video. If you have any suggestions, put that in the comment section. And if you do choose to subscribe to this YouTube channel, please don't forget to hit the notification bell. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.